Hey, how are you doing, guys? I'm Dahan. For today's video, we're gonna talk about linear regression, and I will give you a quick introduction about deployment with fast AI. So let's get started. These are objectives for today's video. So first of all, we're gonna talk about linear regression, the difference between stochastic gradient descent and gradient descent, and the last part is about deployment with fast AI. These are outlines for today's video. So first of all, we're gonna talk about an introduction to stochastic gradient descent, define our task, what is linear regression, create our data, randomize the data, define the weights and bias, create our output, plotting the results, what is cost function, and we are going to use a mean square error, gradient descent, and the last part is deployment. So let's get started. Okay, here's my notes. So for our task today, we are going to use basics library from fast AI. So first of all, we need to import it. So this cell here is going to import it for us from fast AI 2.basics import all. Let's begin with an introduction to stochastic gradient descent. So it's basically how we fit our model to the data. So what stochastic gradient descent is going to do is to select random batches from our data and fed them to our model. So it's an optimization technique like Adam that we saw in the last videos and commonly used in neural network. Let's define our task for today's video. So we are going to create 100 points to use in our fake model, and then we will fit our model to these points. So it's a linear regression task. Okay, so let's get started with linear regression. So what is linear regression? It's a type of statistical modeling used to predict a numerical outcome variable based on one or more predictor variables. So what this mean? For example, let's imagine that we have data about homes and we need to build a model that can help us to predict a home prices. So, okay, here's our data. We have data about the number of rooms on each house, the area of each house, the number of kitchens, and so on, and we have also the price of each house. Okay, so the price of house is going to be our outcome variable, and the number of rooms, the area of house, and the number of bedrooms, and the number of kitchens, and so on is going to be our predictor variables. Okay, so here's the idea behind the linear regression. So it's going to find a linear relationship between the outcome variable and the predictor variables, where the coefficients of the linear equations can be used to make predictions for new data. What is the coefficients of linear equations? Is m and b. So what is m and what is b? M is our weights, b is our y's. And here's the equation of linear regression: y equal m times x plus b, where y is our outcome, which is our predicted variable, x our input, and m our weights, b our bias. Okay, so now we are ready to work with our task today. So first of all, we need data. So here we are going to create 100 points by using torch.ones. So first of all, we define variable called n and pass it 100, which is refers to the number of points that we want to create. And then we define our x, which is our inputs, by using torch.ones, pass it the number of points that we want to create and the size of our data. So what this function is going to make for us is going to make a data with 100 rows and 2 columns. So n refers to the number of rows, 2 refers to the number of columns that we want to create. Here we print the length of our x, which is our input. So the length of our x is 100. And here we print the first 5 rows of our data. So as you can see here is the first 5 rows, and our data is 2 columns. Okay, so now we need to randomize our data. So as you can see above, our data is going to be all of ones. So we need to make it randomize between the interval -1 to 1. So I'm going to use a uniform distribution. So here we are going to pass the first column of our data. So x column comma 0, which is referred to the first column of our data, pass it to uniform, and pass the uniform the interval that we need to randomize our points to it, which is -1 to 1. And here we print the first 5 rows and the shape of our data. So the first 5 rows, as you can see, is randomized, and the shape of our data, which is 102, 100 rows and 2 columns. Okay, so now our data is ready. We need to define our weights and bias. So as I told you, the linear equation is y equals mx plus b. So now we have x, we need to define m and b and y. So let's create first our weights and bias, and with them we can create our y's. Okay, so let's define our weights and our bias. So here we define our weights by using tensor, passed 3 and 2. So this part here is going to create 2D tensor M with shape 1 and 2, 1 row and 2 columns, and value 3 and 2 as we pass it. And this part here is going to print M with its shape. So as you can see here, M is tensor with value 3 and 2. And here we define our bias by using torch.rand, passed the number of points that we wanted to create. So this part is going to create 100 random points for us. And here we print the first 5 values of our P and its shape. Okay, so here's my notes. And now we are ready to make our y's. So as I told you, the linear equation is y equal mx plus b. So here we perform a matrix multiplication between x and m. And note, you may get this error, which is a size mismatch error, because this error here indicates that there is a problem between the size of the two matrices. Okay, and here's my notes. So the size mismatch error indicates that there is a problem with the shape of two matrices or tensors. And here we plot our results by using BLT.scatter, passed our inputs and our outputs. So we passed the first column from our x's and our y's here, and here's our data. Okay, so the weights task is to minimize the distance between the points and our line, also known as make a line with the best fit. To make sure of this, we are going to use a cost function. Okay, so the cost function, also known as loss function or objective function, it's a mathematical function that used to compute the difference between the predicted values and actual values in machine learning model. The goal of the cost function is to quantify the error between the predicted values and the actual values, and then use that error to update the model parameters in order to make better predictions in the future. So our goal is to make our cost function as small as possible. Okay, here we define our cost function, which is the mean squared error. So it calculates the distance between the prediction and the actual value, then squares this distance and then average it. So let's look at the code. First of all, it's going to calculate the distance between y hat, which is our prediction, minus y, which is the actual value, then squared this distance, and then calculate the mean. Okay, and here's my notes. So we are going to use mean squared error, which is calculate the distance between the prediction and actual values, and then square this distance and then average it. Okay, so whenever we want to train our model, we're trying to predict what M is in terms of how to fit it best. So here we take an example with new weight A with values 0.5 and 0.75, and then we calculate our prediction and our cost function. So let's see the code here. Here we define our A by using tensor, pass it as the values 0.5 and 0.75, and then we calculate the prediction by using a matrix multiplication between our input x and our weight A. And here we calculate our cost function, which is mean squared error that we defined, pass it our prediction and our actual value y. And here we plot our results. So the first line here is going to plot our data, the actual data. So we pass it our input x and the actual y. And the second line here is going to print our model prediction. So the orange point here is our model prediction. So as you can see, our model doesn't quite fit, so we need to update our model weights. So we need to train an optimizer. Okay, so here's my notes again. And for the optimizer, we are going to use gradient descent, which starts with some parameters and then move towards new parameters to minimize the function by taking steps in the negative direction of the gradient. So first of all, we need to define our parameters by using nn.parameter, and then we are going to run our optimizer to update our parameter to minimize our cost function. So here we define our parameter, which is our A that we defined earlier, and then we are going to use this A to train our optimizer. Okay, so let's create our update function, which is going to check if the current A is improved. If so, it will move even closer. And here is the code. So first of all, it will going to calculate our prediction, which is our y hat, by using a matrix multiplication between our input x and our parameter a, and then it will going to calculate our loss function. And this line here is going to check if the iteration number I is divisible by 10. If so, it will print the current loss. And loss.backward here is going to compute the gradient of the loss with respect to matrix A using backward propagation. Okay, so this part here is going to update our matrix A by subtracting its gradient multiplied by our learning rate, and this line here is going to reset the gradient of matrix A to 0. And here's my notes. Okay. Here we define our learning rate LR, which is going to be 10 to the power negative 1. And here we train our model with 100 epochs, and then we call our update function that we defined above. So here is our losses. So as you can see, as we train the model more, our loss is going to decrease. Okay, so let's compare our new A with the old ones. So the first line here, we are going to plot our points, and the second line here, we are going to plot our new A by using this function here. So this function here is going to remove all the gradients because we just want the evaluations. And the last line here is going to plot our previous predictions. So the blue points here is our data, and the green points here is our previous predictions, and the orange points here is our new A. Okay, so let's go with the final part. So I will give you a quick introduction about deployment with the Starlet framework in fast.ai. Okay, so here's the server code looks like. And I will go with the important part that you need to care about. So the first thing that you need to care about is when you export your model, you need to be able to access it remotely. So you can pass the URL of your exported model here. Okay, and the second thing that you need to care about is your classes, which is going to be the labels. So you need to pass it here. Let's go with the notebook again. Now let's go with what we are gonna care about. So first of all, we are going to look at images. So you can have a few different types of inputs on your server. So you need to think about what is your use cases. So user can input one image at a time, or they can input a URL, or they can drop a zip file for us to analyze a bunch of images at once. So here we declare our getBytes function. So it's okay if it doesn't make sense to you for now. You will understand why we care about this later. Okay, so let's go with an individual image upload. So here we accept the request, and here we are going to get some bytes of the file that's attached, and here we are going to use learn.predict method, pass it our image bytes, and 0 here is going to return back to us the predicted label of that image. So let's go with the URL. Now instead we are going to use getBytes function and grab the URL that was passed in, and again we are going to use learn.predict method. Okay, let's look at the diff file. So now we have a user that uploaded a zip file. So first of all, we are going to create a directory called downloaded images, and then we grab our images, and here we are going to load our learner, and then we are going to use a testdl function, pass it your learner data bunch and the image file names. And here we are going to call a learn.getPredictions, pass it our data loaders, and with decoded equal true here is going to return the original class names. So here we are going to remove the folder, and we are going to write everything into CSV document and return that CSV document to user. And here we can do the similar thing if we expecting that a CSV file with image URLs. So let's go with Tabular. So tabulars are different because most of your work is done by sending a very large data frame into your model for analysis. So we are going to recreate what we did but load it into a pandas data frame. So here we get a file, and then we are going to read that file into string IO, and pandas can read that file into a data frame, and then we are going to load our learner, and all of this part here is the same as we did earlier, except that we need to adjust the JavaScript to accept a form. So here's the code for this. Okay, so finally the text, we are going to have a request, then we are going to get the content, and the last thing we are going to call learn.predict on our content. Okay, so that's it for today's video. Hope you enjoyed.